Welcome, everybody. I'm Ryan. Thank you, John. Thank you, Scott, Martin, Afim, Kim, Jonathan, and Senate for joining. And for all of you who will be watching this later on the recording. One quick note is I wanted to give Scott Ford a shout out. I'm currently wearing the shirt that he won in last month's coding challenge competition, and we've got one on its way to you, Scott. So for everybody else who's watching this later and wants to participate in the coding challenges, a shirt like this or some other fun swag is one of the things that you'll get in return for your hard work. So just a quick check, because it kind of looks like some people are still frozen. Everybody can hear me all right? Sweet. Okay, great. Thank you, Senate, and everybody in the chat. I'm going to go ahead. So today we're going to talk about RESTful APIs. I'm going to go ahead and start sharing my screen. Just give me one sec. All right, so REST APIs with Java and Spring. So we're going to talk about, for the first couple of minutes, I'm just going to briefly discuss what the idea of a REST API or RESTful API is. And then we're going to do a little bit of a demonstration on how to create a RESTful API, as well as how to integrate with a third-party RESTful API out there on the internet, and then open up and have some time for Q&A afterwards. So I'm sure all of you have heard of this term REST API, or most of you have heard of this term REST API, RESTful API. And the big first question is, what is it, right? And so simply put, a REST API is a web service that allows software applications to communicate programmatically over the internet. And obviously there's several ways that things can communicate over the internet, but basically one of the most common ways that software applications and web services communicate with each other is using a RESTful API. And as an example here, let's say this is just an example of your app. Let's say that your app here in the center is some kind of stock trading app or some kind of financial trading application, right? And the way that you're going to make your trades is that you're going to pay attention to stock data coming from, let's say the New York Stock Exchange, and you're going to pay attention to weather. Let's say that you're paying attention to severe weather events like hurricanes and tornadoes, droughts, fires, etc. You're also going to be monitoring headlines. For instance, if you're seeing that Hurricane Elma has been upgraded from a Category 3 to a Category 5 or something like that, right? That's information that might be important and useful in the trades that you're making, because you might basically assume that certain stocks are going to go up or down based on these based on this weather. And then you're also going to execute trades on a given trading platform, right? So the way that we do this, for the most part, and there are some exceptions, but the vast majority of applications, the way that they do this these days is via RESTful APIs. So my application will make a RESTful API request to get headlines, let's say from any number of news services. They all have RESTful APIs that they offer. My RESTful API will also make requests to, let's say, weather.com or whatever your favorite weather service is. They've all got RESTful APIs. It will also make requests to various different stock APIs that deliver stock information, current pricing information, etc. And then it's going to make requests to my actual trading platform to execute requests, right? So my application will pull down all this data from all these various sources, and then based on the analysis of this data, may or may not execute an actual trade on this trading platform. And so obviously what you can see here is we've got several different applications. We've got 5 applications in this little example app. And the way that they're all communicating, the mechanism is a RESTful API. So how does a RESTful API do this? In short, it piggybacks on the HTTP protocol. So the HTTP protocol is the Hypertext Transfer Protocol, which is the way that the internet already works, right? So back when it was originally invented, the people understood that there was a certain number of actions that you were going to need to take across the internet for things to work. And they go along right with this anagram, not anagram, but abbreviation, CRUD, create, read, update, and delete, right? Which in the HTTP world are called get, post, put or patch, and delete, right? So every website that you've ever been to, every web page that you've ever visited, every single URL that you've ever put into a web browser to go get the information from a specific website or server, you've been making a GET request using the HTTP protocol. And behind the scenes, for instance, when you create a new account on a given platform, what's happening behind the scenes is that account is being posted to the server, right? Because you're creating a new account. That's called a post request. It's like you're sending something in the post, but you're creating something. If you want to update a resource, like let's say I want to update my password on a server, the request that's being made behind the scenes is called a put request or a patch request. They effectively do the same thing. Put is meant to update an entire record, and patch is meant to update just a piece of a record. That being said, most people kind of just stick with one or the other because they're essentially the same. And then delete is self-evident. It's for deleting elements on a resource, such as a server. The RESTful APIs are not a protocol, right? They leverage the HTTP protocol to basically piggyback on the the mechanism of the internet of how it's working. But a REST API, there is no protocol around it. There's just agreed upon conventions. And some of these conventions are the way that we structure our URLs, the way that we use headers, because every HTTP request also has this idea of headers, which is just kind of some basically metadata that gets sent along with the request. And then most commonly these days, RESTful APIs communicate using JSON, which is JavaScript object notation. It's just another form of text to that we all agree upon, that basically you could map objects, be it in any language, JSON, Java, Python, etc. You can map this idea of an object or a collection of data directly into text that can be sent over the wire, right? And that's JSON. And then there's this idea of authentication, authorization, and throttling, which is very common. So authentication is just obviously a lot of RESTful APIs are going to need you to authenticate. For instance, if I want to create a RESTful API that connects to my bank or to some service like Salesforce or HubSpot or that trading platform from that example, I want to actually execute a trade, I'm clearly going to need to authenticate against that. Behind the scenes, we also have this idea of authorization. So once authenticated, what can you actually do, right? So if I authenticate against that trading platform, I'm not going to be able to, I can execute my own trades, but I'm not going to be able to execute trades for somebody else or delete someone else's account or something like that, right? So I'm going to have specific authorization for the kinds of things that I can do. And then oftentimes with APIs, RESTful APIs are going to have this idea of throttling, where the API, the RESTful API provider basically says, you can have 1,000 requests per day. After that, you're going to be charged X amount, or after that, you're only allowed 10 requests per hour or something like that, which is, we can otherwise, if you just have a fully open API, it can be, there's bots that can be written against it very, very quickly to basically overwhelm that RESTful API because it's publicly available on the web. So I just mentioned these, but the HTTP request methods that a RESTful API leverages are I think there's 10 or 12 of them, but the most common ones are get to retrieve data, post to add or create data, put and patch to update data. And by that, I mean on the server, and then delete. And there are others such as info and options, etc. And that basically will just give us more information about what this RESTful API can do for us. And as mentioned, this is the way that the Internet Protocol HTTP already works, and RESTful APIs just piggyback on it. So one question that Gilad actually mentioned, which I think is a great one that can cause a little bit of confusion, is what's the difference between an API, a REST API, and an SDK? So a standard API is, as I point out here in Java, for instance, the system.out.println, that method that we can call that's inside the Java class libraries, that's known as an API, right? It's an application programming interface. So the authors of the Java programming language, they created all of these APIs, basically the entire Java programming language is just filled with APIs that developers like us can leverage to do whatever it is that we want to do, right? So that's kind of the general term API. And then we've got this idea of a REST API, and REST stands for representational state transfer. It's not like snoozing or taking a rest or anything. REST API means that it's a web service that two different applications can use to basically communicate with each other. And so that I can use, a couple of examples that I'm going to show you, but we've got like a tasks API or the New York Times API, or, there's literally hundreds of thousands, millions of RESTful APIs out there. And every company basically provides one, right? So if I want to integrate with Salesforce programmatically, or HubSpot programmatically, or PayPal programmatically, or weather.com programmatically, or whatever it is that I want to do programmatically, I can interact with those web services using their REST APIs. So REST APIs are web services. And then an SDK is a standard development kit. And what that means is, and here I mentioned the AWS SES SDK. So AWS is Amazon Web Services. SES stands for their Simple Email Service. And SDK stands for Standard Development Kit. So because AWS really wants us developers, and AWS is just one example, there's literally millions of these SDKs out there. But because in this example, AWS wants us as developers to be using their simple email service, right? It generates revenue for them, and it kind of locks their systems into our systems. They create what are known as standard development kits. And it's basically a Java, in the case of Java, it's a Java library that we can import into our project, and it makes it very, very easy to use SES. So as an example, if I go to AWS SES Java example. Looks like my internet is being real slow. Well, while that's loading, we'll come back to that. So just a silly little self-quote here. There's basically a REST API for everything. And that's Coding Nomad's quote. And a few examples that we're going to look at are the Coding Nomad's Tasks API, the New York Times API, the Kanye REST API, which is just a funny one, the Cocktails API, Meals API, and this fun list of REST APIs. There are literally millions of them out there. Okay, so back to the AWS SDK, just to clear this up real quick. This code, notice here in these import statements, we've got import com.amazon AWS. All of these different packages and classes. These are not these packages and these classes, like the simple email, model.message, model.send email, etc. These are not included in the Java class libraries, right? This is the Amazon SES SDK. And the way that I can use this in my application is by importing. I basically could go to the Maven repository. I could search for AWS SES, and I would do it right now if my internet wasn't moving so slow. I can download that, or I can add it to my palm.xml for Maven, or my build.gradle for Gradle, if I'm using either of those to manage my dependencies. And then once I've got that imported into my project, I can then import these classes and libraries into any given one of my classes. And I can basically send an email using Amazon's simple email service using this block of code, right? And Amazon, AWS, they're the people that wrote this SDK. So it's called a standard development kit, and it makes it easier for us developers to integrate with their services using SDKs. So it's a little bit different, right? API, something like system.out.println in the Java class libraries. REST API is a web service that applications use to communicate with each other. And then an SDK is a simple or standard development kit that companies create for us developers to more easily integrate with their services, right? So let's take a look at a RESTful API. This is a sample demo.codingnomads API, and it's a tasks API. And what a RESTful API does, and right now we're using the web browser to execute GET requests. Any time that you go to any website through a browser, behind the scenes, what's happening when you hit enter, right, like that, is that you're making a GET request. And then I've got a what's called a JSON prettifier. It's a little plugin that you can add to your browser that basically prettifies or formats the JSON to make it a bit more readable, right? So what we've got here, this is JavaScript object notation. Curly brackets mean object, square brackets mean array, and it's basically a key value store. So the key here is data, and the value is this array of, in this case, user objects. So here I can see that this is a single object, and it details a single user, right? And what's interesting about a RESTful API, I mentioned that URL structure is one of the conventions. So here, if I just said this is the root task API, and if I just said /users, which will give me a list of all users, right? So let's say I want a single user, I would just say users / let's say 5, and that will give me just the user with ID 5. And then I've also got this idea of tasks, because this is like a task API that manages users and tasks, right? And so here I've got all tasks, and I can say, let's give me the task with ID 5. And here's that single task. And furthermore, you can do things like give me the users /5 / tasks. So this will give me all the tasks for user ID 5, right? And then I can do, I can take it a step further. I can say, like, for instance, completed equal true. Maybe complete, none. How about complete equal false? So this will just give me the incomplete tasks for user with ID 5. And that structure is a convention, right? So what we do is we try to make our URLs as conventional and basically predictable as possible. And this RESTful API would be the web service, basically, that your front-end application, like your JavaScript, whether it be React or Angular or whatever, it's going to be making these requests behind the scenes to get this data and then parse that data and populate the HTML page, right, with a list of a user's tasks or a list of users and so on. Just for fun, this is a silly Kanye REST API. So APIs can be super complex. They can also be really, really simple and funny. And so this is just a RESTful API that returns quotes from Kanye West, which is kind of funny. There's also a bunch of other APIs out there. Like here's this fun list of 100 cool and fun APIs, and I just pull it up because it's really just to show, here's APIs about animals, here's APIs about anime, here's APIs about art, here's APIs about crime, cryptocurrency, food. That's where I pulled up these ones. So the free meal API, for instance, this is the documentation, quite useful. And here I can just copy this URL and hit it. And let's say, what meal are we interested in? How about, arrabbiata, whatever that is. And so this returns an array. It's got a single element in it, but it basically is the meal, spicy arrabbiata penne. And it's got some instructions. It's got the ingredients. So if I wanted to create a web service, for instance, or a website that had all these meals and their instructions and their ingredients, etc., I could use this API, the MealDB API, to power that, right? So I could, for instance, let's see if I can get a list of all meals. Look up all meals by first letter. So in this array, I can see that there's 4 items. So here it's just giving me the first 4 meals that start with A, right? So in my website, I could basically have like some letter picker or a search bar where people could pick meals and like search for meals. I would make that request for all meals that start with A. And then with this information using JavaScript, I could populate the page, right? That's one way to create a website. Another way is using what's called the model view controller, which I'll kind of skip over for now. There's some other fun ones, like this is a cocktail API by the same people. And I'm just showing you these to show you that there's really a REST API for everything, right? The United Nations has them. The one that we use a lot is the New York Times API, right? This is the article search API from the New York Times. And so here, what I've actually searched for is London, but let's search for coding. And these are all the articles being returned from the New York Times about coding right now. And again, so I'm using my API key here, which identifies me as the person that's making this request to the New York Times. And after a certain amount of requests, they'll actually throttle me because they're not trying to let any single developer overload their servers, right? But the New York Times very much wants other web services and other websites and other news aggregation services like Apple News or any news aggregator online. They want those services to be including the New York Times articles in their news, right? And the thing that you have to do is basically just quote and cite and link back to the New York Times. That's basically their terms. You can use all the stuff as much as you want, but you have to link back to the New York Times. So this is this, kind of quick overview of what a RESTful API is. We've done everything right now via GET requests. If I wanted to do a post request, like I want to create a user on, let's say, this task API, what I need to use is actually what's called an HTTP client. A very common one is Postman. And this HTTP client allows us to make requests that are not GET requests. So we can make put, post, patch, delete requests, which you cannot do using a web browser, right? Web browsers basically only support GET requests. So here I've already got the URL of this. Will it not let me? Let's see, just make sure this works. Looks like it does work. Here I can also make a number of different types of requests. So these are all different types of requests. Let's say I want to make a user, right? So I'm going to switch over to the post. In the headers, I'm going to make sure that it has content type application JSON. This is just kind of a boilerplate thing that we got to do every time. This tells the server what type of data is coming there, like how it's formatted. And then in the body, I'm going to go over to raw, and what I do is actually send JSON representing a user to the server. And I know that in my particular case here, the ID is automatically generated in the database, as well as the created at and updated at fields. So I'm just going to, let's say, Coding Nomads REST API, my first name and last name, and let's say codingnomads@gmail.com. And that's it. So this is the JSON that represents a single user. And what I want to do is I want to send this information to the server to create this new user. So it's a post request. This is the URL. In this case, there's no authorization required. Please don't crash the server too much by creating any bots on that. Here's the JSON or the HTTP request body that I'm going to send over, and I'm going to go ahead and send it. And it looks like that worked because I got a response with an ID, first name, last name, created at, etc. So now if I go back over to the browser and I go to users, the most recent user is there. There we are. So now we've created that user. I could also update that user with let's say a put request. So let's change this over to put. And let's say I want to go with, I don't want that space there. I want to update it like that. Looks like maybe that didn't work. Beauty of live demos, but I'm not going to debug that right now because I want to get to the actual live demo of creating an API. So let's just see if that did or did not work here. Did not work. So excuse me, but we'll come back to that. So let's say I want to create my own RESTful API from scratch using Java and Spring. So I'm going to go to the Spring initializer here, which is just a simple little web service that allows us to quickly and easily create a RESTful API, sorry, a Spring application. And in my case, my internet is just crawling. While this is loading, any questions or anything I can help anybody with at the moment?
I think there's one thing that I'll add. You were saying earlier that SDK for standard development kit, and I'd always refer to them as software development kits, SDK.
Oh, sure. Yeah.
So if you're doing, so if you're doing something like, way back in the day, if you were doing Windows development, and you needed to develop on that, you could, create windows, create menus, have the window do things, and then that SDK just stood for, at the time, software development kit for Windows. There's one for Android. There's one for Mac. There's one for KDE Linux and GNOME Linux and so on and so forth, Qt and GTK and so on and so forth. So there are different types of kits that are available, and they're not just limited to web-based applications.
Right, nice, yeah, perfect. Thank you for sharing that. Panos actually also mentioned that what I was missing here was my ID. So where was that? So the ID of my,
the ID was back in Postman when you were trying to do the put.
right, 387. So I think that is, so when I'm doing a put, I've got to provide the ID of the user that I'm trying to update. Let's see if that'll work now. And it did. So you can see that the last name has been updated for with the underscore. So thank you, Panos. That was absolutely correct. So back over here in the Spring Initializer, this is just a simple web app for kind of quickly starting a new Spring application. Spring is just a framework that sits on top of Java that facilitates us writing professional grade, enterprise grade applications relatively simply. So I'm going to go with the group ID. This is just kind of details about how the project is structured. I'm going to go with column.coding nomads. Let's call it rest dash demo. And this will be a WAR file because it's a web application. That WAR stands for web application resource. We'll go with Java 11. I'm going to add some dependencies. We're going to do Spring Web. And I think that we'll use Spring Data JPA. I think I'll just start there. And then I'm going to go ahead and generate that. And then over in IntelliJ, I'm going to create a new project from existing sources. Those existing sources being that what I just downloaded here. What was that called? restdemo.zip. Oop, not the zip. This is a Maven project. And so Maven and Gradle, just so you know, you'll hear those a lot. Those are just services, applications that we use to help us manage our dependencies. Because once we start getting into larger projects, we have all these third-party external dependencies. And Maven and or Gradle, which are effectively equivalent. Maven's kind of older, Gradle's a bit newer. You'll find them used kind of interchangeably throughout the Java software development world. So that's what the Maven project or Gradle project is all about. And in a Maven project, we've got this idea of a POM file, project object model is what that stands for. And it's an XML file that basically tells our system, the JVM, the Java class path, basically what dependencies, what third-party dependencies we're going to use. And then Maven will automatically download those dependencies, which you can see it doing down here, this little updater. It's actively downloading each one of these dependencies and installing it, not installing, but placing it on my local system, and then informing the JVM where that dependency is, so that when it's time to use that dependency, Java, the JVM will be able to find it. So that's currently what's happening. Now I'm just going to give it a second to finish resolving. And Scott, I see your question as well. And basically I can wait because I can't do anything until these dependencies get downloaded. Sorry about my internet speed here today. So Scott asked, just to confirm my understanding, would it be accurate to explain APIs as a means by which someone can interact with a server or database? Yes, and I would say specifically server, because it's going to be the server that's interacting. It's going to be the application on the server that you're interacting with via an API. It's that application on the server that interacts with the database. So I would take out or database. An API is a means by which someone can interact with an application that's running on some other server somewhere. You're welcome. And this is just taking it sweet, sweet time. So I'm gonna, just while we're waiting, let's go look at the New York Times API again. So here, this is basically, we've searched for this coding, and how about we search for, I'm currently in Dallas, so let's search for Dallas. I just made my internet even slower. It's very, very slow today. And here we've got the top 10 articles that mention Dallas currently on the New York Times. And so if we look a bit closer, we'll see that it's broken down again into all these key value pairs: abstract, the URL, snippet, meaning like the headline, the lead paragraph, where it was printed in section B on page 10, as well as various multimedia. So like this is an image. If I go to, I'll just copy this URL. If I go to nytimes.com and I paste that, here's this image. And if I go to this URL, for instance, where that article is, there's a very good chance we're going to see this image right around the top, as well as the lead paragraph, the snippet, etc. And the New York Times allows you to use all this information on your website in whichever way that you want, as long as it links back to the New York Times. And there's that image coming up, slowly but surely, right? So this just goes to show you that via this RESTful API in JSON, I've got access to all the information that you would find, not all of it, because it doesn't give you the whole article. It just gives you the lead paragraph, the snippet, the URL, the images, the author, all kinds of additional information. But then in my Java application, which I hope to show you briefly, I'm running a bit behind time here, it's quite easy to map this JSON information onto Java objects in my application, which if these dependencies ever finish downloading, I think it's because this is this 252 version. I probably should have just stuck with another version that I've already used on my machine, because it's downloading all these behind the scenes dependencies that this Spring application is going to need. But I wanted to show the process from beginning to end, for instance, using Spring Initializer to start a project and download it. And it'll just be another second here.
While that's going on, Scott's got another question here for you. It's asking if, is there, or what is the difference between an API and a programming language versus an API that interacts with a server? So the difference between a programming language API and a RESTful API.
It's just a conceptual difference, right? An API, for instance, the system.out.println API, and I'm just using that as an example. Basically, any method that you call in Java that's part of the Java class libraries would be called a Java API. API just stands for Application Programming Interface, right? And so anytime you're calling some method or interfacing with some kind of code, function, method, class that somebody else wrote, or let's say that you're using any kind of IO class to read in a file, or you're using any kind of you're using like the MySQL driver to interact with the database, right? What you're doing is you're interacting with the APIs in that MySQL driver. You're interacting with the API that some Java developer wrote to help us open a file, right? And so it's a little confusing, but it's really still just an application programming interface. A REST API is conceptually different, right? It's an application that exists on another server, and we communicate with that application over the web using the HTTP protocol to basically piggyback our way, piggyback on the HTTP protocol to basically ask a question from weather.com, like what's the weather today in Louisiana, in New Orleans, or what's the current price of the Tesla stock, or what's and I want to ask these questions to these third-party services. That the way that I would do that would be a RESTful API. Does that make sense? Got it. Yeah. And then maybe I should just, let's see if I can just open up an existing project that I've already got. How about, okay, so I think I'm just going to use this one. This just comes from the Spring Guides website. Spring has a number of fantastic guides. This is for serving web content. So basically how to create web applications, like that serve web pages instead of REST APIs that serve JSON. So I'm just going to get rid of a couple dependencies that we're not going to use. We need that. Okay, so I'm just going to create a new package for us to play in. It's still working. Let's call this REST demo. All right, so what I'm going to do here, because I'm using Spring, and Spring provides all these fantastic tools and libraries and classes for me to use, I'm going to create a new class, and let's call it user controller. And what I'm going to do here is I'm going to add an annotation that Spring provides called REST controller. And what that does is it tells Spring that this class is going to be used to receive incoming API requests. And I'm going to say that this it's going to request at request mapping, all URLs that start with /user are going to come to this file. And then I'm going to create an endpoint, say get mapping. And this is a public, let's go with array list of type user, which doesn't exist yet, get users. And in a user is simply going to have a, let's say, string first name and string last name. And let's go with int h. And then I'll create, I usually like to have a fully qualified constructor, an empty constructor, and I'm just hitting control, and I'm hitting control enter to pull up this little generate method. And I'm going to create all the getters and setters. There's also this library called Lombok, which will basically auto-generate all of these constructors and getters and setters, et cetera, for us, which I use frequently. But for right now, I'll keep it the old-fashioned way. And I'm going to create a little service. Typically, this would be off a database, which I was going to do, but I'm running a little shy on time. So I'm just going to fake it by creating a list of users. And in this class, I'm going to use Spring. I'm going to annotate this class with @service, which basically tells Spring that this is a class that I'm going to be auto-wiring or injecting into other classes. This has to do with dependency injection and what's known as inversion of control. And it's Spring's way of automatically injecting the class level dependencies, like the objects, the classes that we're going to use inside of our application, into one class, from one class into another really nicely. And sometimes it seems like, why do we have to do this? Why don't I just create an object of this class? Because behind the scenes, a lot of the stuff that's happening when I'm using these annotations like @REST controller and many others is that I'm inherently using Spring's inversion of control container or dependency injection paradigm. And if I break that paradigm, I basically have to use it all the way through, right? So this will make more sense in a second. But inside this service, I'm going to create, this service is going to have an array list of users called users. And then in the constructor for this class, I'm going to actually just create a couple of users. So I'm going to say users.add new user. And I'm going to give them, let's say, Ryan Guzman. Work. And We'll just start with two users. And then I'm going to create a method in here that just says public array list of type user, get users. And this is just going to return users. And so in here, what I'm going to do is I'm going to auto wire that user service that I just created into this file. And basically what that means, and this makes more sense, if you're more curious about this, we can chat further and as well as the spring course that we're just now launching. It goes into this in detail about what this all means in version of control and dependency injection. But what I'm effectively saying right here in this auto wired is that I'm telling Spring that I want that user service class that I just created. I want it to be wired or injected into this class, right? So I can use it. And then I don't have to manually create that object anymore, which at first seems like, why? Why would we do that? Why don't we just create that object? It's because it has kind of cascading effects, and using Spring's inversion of control container gives us all these really, really helpful features to make our lives easier. And so we just kind of go with that flow. So here all I do is say return user service dot get users. And I think that's it, right? So what I've just done here is I've created a single endpoint, and this whole class is mapped to this /user endpoint, which is the URL. And I'll deploy it in a second to show you how to hit that. And then I've said at get mapping, meaning if there's a get request to /user, or let's go with users, I want it, if there's a single get request with no other information other than /users, it's going to direct that request to this method. This method is just a typical Java method. It's called get users. It returns an array list of users. I did this user service.get users data over here because I want to keep all of this logic about creating users and the users array list, et cetera. I want to keep that out of the controller, primarily because there's going to be other places in my application where I might want to get users or add users or update a user. And I don't want to have to call this controller from inside my application. This controller faces the outside world and it takes requests from external clients, right? So I basically delegate all the work that's going to need to happen to another file where it's much more generic like this. It has no special HTTP requests. It's not doing any get mapping or post mapping. It's not accepting connections from the internet, right? Whereas this class is. So if I deploy this, and what's happening now is that it's building the application, it's packaging the application into what's known as a WAR file or a web application resource. And because I'm using Spring Boot, which is just a version of Spring that is called opinionated, and it assumes a few things for you. It assumes that when you run this application, that you want to deploy it on a Tomcat web server, which is how there's many different types of web servers you can deploy your applications on. Tomcat is probably the most common one, Apache Tomcat. It's just a web server. It's basically a container that we can deploy our application into that makes it available as a web service. And Spring Boot comes packaged with an embedded Tomcat server. So when I start this application, it'll build the application and it'll deploy it, as you can see right here, to Tomcat on port 8080, right? So now to test this application, I go back to my browser and I say localhost 8080/users. Uh-oh, I got an error. Not found /users. Beauty of a live demo. Anybody see the error? REST controller request mapping /users at get mapping /users.
Are you using HTTP or HTTPS? Because it was initialized with HTTP. I know for
HTTP.
me, my browser defaults to my browser defaults to HTTPS all the time. So
Just try that again. Sometimes a little restart just does the trick. Looks like this other one finally finished importing all the dependencies.
it's kind of fun to see. It's 2021, and it's the middle of 2021, and then when you go to compile Spring Boot, the first thing that pops up is really cool ASCII art.
Yeah. Okay, so this is acting a little weird. Let's see if I just get the.
So it's running the comedy application. Is that what you expected to happen?
Yeah. Maybe what I need to do is put this package in here. Basically,
As opposed to REST?
It might not, it just might not be catching because it's in a different package. The this at Spring Boot annotation, which includes the at component scan annotation. It scans for components in the application to load. Because I did it in a different package, maybe it missed it. So I'm going to try restarting it now. Basically, because all the dependencies were taking so long to download in that other application, I just took another comedy application. It's a demo actually from the Spring course. And I'm just trying to use it on the fly. And the original application is called Comedy Application, and it serves jokes as a web app. This might fix it, I think.
Wondering if I was trying to fire up the comedy application, maybe hopefully that fixed it. Because if it's running comedy, then that endpoint won't be there.
I actually broke up a bit as you were talking, John. What'd you say?
I was basically concurring with what with what you had done. If the comedy application was what was running before, and the user controller was in a different place, maybe that endpoint just didn't exist.
Unable to start due to missing servlet web service factory. Oh, that's why. Yeah, thanks for joining, Scott. And as well as John.
Scott. Yeah.
All right, so looks like this launched. Let's give it another go. Fingers crossed. Hey, it worked, right? So this is just a simple GET request that will get 2 users off the server. Typically, these would come from like a database. I just faked it and made them come out of an array list in that service. And I know we're running short on time, and I'll be able to stick around for anybody that wants to ask questions. But I want to take this just a step further. And in the user, I think if I put this at request mapping back up here, I think the problem was where it was in the package. So let's say that I want to create users through this service as well. So I'm going to say at post mapping, and this is going to be public. I'll have it return a single user. It's going to call it create user. And inside the body of the request, it's going to say at request body, user. I'm going to go ahead and import that. And here I'm going to say user service dot create user. It's a method that doesn't exist yet. I'm going to pass in this user object that was passed in right here. I'm going to go ahead and create that method. And in here, I'm basically faking the database, but I'm just going to say users dot add user, which is this parameter that's just getting passed in right here. And then back in my controller, I'm actually going to have this return all users just so that we can immediately see that indeed that user was added. Then I'm going to say the same thing, return user service.get users, right? And so the interesting thing here is that this post mapping, right, it will only work if the incoming request is of type post, if the HTTP request method being used is a post request, right? But the URL will be exactly the same. And that's one of these URL conventions that I was mentioning, where instead of having a bunch of different URLs like get all users and create user and update user, right? It's a single URL, and the method that it will get directed to inside your application and the action that will be taken depends on the type of HTTP request that's being made, which is a very useful thing in simplifying our applications, especially when they get quite big and complex. So I'm going to restart this. Cool. So now when I go to this localhost 8080 users, I'll still get these 2 users. But now I want to create a user. So what I need to do is actually use, again, an HTTP client like Postman. And my URL is going to be localhost 8080/users. This is going to be a post request, no authorization. Again, I'm going to say content type. This is just boilerplate. We got to do it every time. Tell Spring what kind of data we're sending it, which is JSON. And then in the request body, I always just put it in raw. I'm going to paste in a new user. Let's go with John Fincher. How old are you, John?
54.
Nice. 54. And if I go ahead and send this, basically, I'm assuming that this request will get sent over to my RESTful API. A new user will be created, added to our fake little database, which is just that array list. And then it's going to return a list of all users, which will return me, Kim, and John. And it did. Bada bing, bada boom. And so the next thing that we would do here, just so you guys know, is that we can very quickly compile or package this application into a WAR file. So I could say package right here. And if I double click that, that'll compile this into what's known as a WAR file, which is just a single, basically compressed folder that contains all these classes. And then using a Tomcat installation on any server, there's 1 or 2 configurations that you have to make to tell Spring not to use the embedded Tomcat web server, but that you're going to be providing your own Tomcat web server. You basically just drop this WAR file into a particular folder on the Tomcat web server, and it makes it automatically available, which is exactly how, for instance, this demo Coding Nomads API that I've demonstrated here with users. It's exactly how that works. The underlying Java file for this basically, it's got a little more in it, but it basically looks exactly like this. It uses a real database, but all we did was package it and then deploy it on a server. And in a future brown bag, we'll go through working with AWS, creating a server, installing Tomcat on that server, and being able to deploy, for instance, RESTful APIs and other applications to that Tomcat web server. So we're actually at time, so I'll stop talking and kind of open it up for any questions that anybody might have. Yeah, hopefully that was interesting and a bit helpful, at least in inspiring your curiosity. Nice, Efim, you called it out. I missed the chat, but you called it out that it was the Spring Boot
if anybody has any
implementation.
questions.
Oh.
Yep. So if anybody has any questions, go ahead. I've made sure everybody was muted except for Ryan throughout the entirety of this. So go ahead and unmute yourself. Go ahead and ask any questions that you have. Yeah, we can go from there.
Hey, Ryan, where do you, like when I was going through the API section, I was trying to pull back some data from the Coding Nomads API. I had to use email as kind of the key to pull back data. If I used like first name or last name, it just would bring back everything, all users. So where in the API do you define that if someone's, posting a or using a GET request, that they can only bring back one user if it's if they use email, for instance? How does that connection get made?
Well, every API is a bit different, right? It's all about that documentation. And so one thing that I can show you, most APIs, the Coding Nomads demo API as well have documentation. So I believe it's Swagger. So this is just some auto-generated documentation that I included in this application. And a lot of the Swagger is a very common, it's just an application that you can use to generate documentation like this. And for instance, in the user controller, it shows you the various endpoints or URLs that you can hit. So there's a get request for /users, there's a post request, put, get. And so this, you actually can't get a user by email. The only way that you can get a user, unless there's a way that I'm not, maybe there's a request param where you can say, oh yeah, email string query. So you can say, basically parameters mean that you can do demo.codingnomads, and then let's say like, what do we call it? Coding nomads at email.com. So you can search for particular users like that.
Yeah,
and it looks like there's a bit of a bug.
Parameters. I was using the parameters to search for it.
Yeah, so that actually looks like a bit of a bug. So that should, on our side, so that should return a specific user. But if you do, like the other way that you can return a specific user is just by putting their ID. Does that make sense?
Would you be?
Yeah.
Yeah. How about if you were to do like email equals and then coding nomads at email.com?
That might be it. Request param. You're right. There it is. Yeah. Nice call, John. So that makes sense, Martin?
Yes, it does.
And did that answer your question?
Yes. Yeah. So I was just trying to figure out why I could only use the email. Obviously, you can use ID as well, but why I couldn't use first name to bring back a single user in the parameters. And that's
right.
because
Okay.
it's only the parameters were only defined as.
Yeah. So that's just basically limitations of what's currently programmed into the API. You could, as the API developer, very, very easily allow another string parameter where it would be like, string first name equal Martin, and it would return all Martins, or string last name equals Desmond, and it would return all Desmonds. That's just not built into this API yet.
Got it.
And what's interesting, this API, the source code for it is actually available on Coding Nomads GitHub. So the actual, this is the live application. And for instance, if you go into the user controller, you'll see a number of common things: at rest controller, at request mapping, two services that are auto wired in, get users, find user by ID, get tasks. So this would be user/ID. This is a path variable, which is defined right here. /task. This is get the users for the task for a specific user. Create user, update user, delete user, and you'll notice it's at delete mapping, at put mapping, at post mapping. So if you're interested in playing with this more, or playing with this task API on your own machine, you can clone it right here from Coding Nomads GitHub. And I'll actually share that in the chat right here.
Very cool. Senate, you had jumped onto the chat. You wanted to have, did you have a question you wanted to ask as well? Okay.
Makes perfect sense. Well, great, everybody. Hopefully, I know I flew through that, but hopefully that kind of unlocks or starts to make a little bit more clear what this whole idea of RESTful APIs are. The idea that they piggyback on the HTTP protocol using GET request, POST request, put, patch, delete requests to simplify and kind of make a convention out of the way that all of these different services communicate with each other. And I'll show you one more thing for those of you that want to join us for 2 or 3 more minutes. Let's look at this task API, and I'll show you how we would integrate this into our application, right? So I've got this request, and the response is actually pretty simple. It's a simple object that has a data array, an error, which looks as a string, and status code, which is an int, right? So if I want to be able to query this API from my application, what I'm going to do is, let's create another.
Did you want to be sharing your screen right now?
Oh, yeah,
Yeah.
sorry.
Thanks, Kim.
Yeah, so basically what I meant to say was, if I want to map this Coding Nomads API into my application, I can do it very, very quickly. So I'm going to create a new class called, did I already create it? Let's call it the Coding Nomads API controller, just so it's evident what it is. And this is going to @REST controller tell Spring that this is going to be a REST API. Say @request mapping, and this is going to, let's say, cn-API, and then going to get mapping, and let's call this a cn response class. And the cn response class doesn't exist yet, so I'm just going to create it. And what this cn response needs to have is fields that map exactly to this API. So I've got a data array called data. I've got a string error, and I've got a int status code. This data object doesn't exist, so I'm going to make it. Oops, I'm not going to import it. I'm going to create it. And inside this class, I need to have this information. So ID, first name, last name, created at, updated at, email. Int ID. String first name. It along. And along. Again, I'm going to do my classic fully qualified constructor, as well as a default constructor, as well as all my getters and setters for good measure. And over in my API controller, there we go. What I'm going to do is I'm going to say cn response equals. I actually need to bring in a. So I'm going to say @bean. That's the one I'm looking for right here. Sorry about that. And when I set this up, I'm basically telling Spring, when this application starts, I want you to create a bean, which is just a managed object in Spring of type REST template. So Spring will automatically call this method. It will provide this REST template builder. It will return the builder.build, which will be this REST template object, which Spring will keep in what's called its application context, which is like a bucket of beans or objects that we can use whenever we want and need throughout our application. So here I'm also, what I'm going to do is auto wire that REST template in here. And then what I'm going to say here is REST template dot get for object, and then let's just create the URL here equals. That's the URL I want to hit. And so I'm just going to say the URL and then the class I want to map it onto, which is cnresponse.class. And then just to demonstrate, I can say for data d in cnresponse dot, I should say response dot get response dot data. In this data class, I'm also going to go create a nice little toString method. That's why there was no get data method. So, and I prefer to use my getter method. So I'm going to say get data. And this will just demonstrate that when I go to localhost 8080/cn API, and it's a GET request, it's going to come to this method. It's going to use this URL, and then I'm going to use Spring's REST template to make that API request. And with the data that comes back, I want to map it onto this CN response class. And the CN response class has these fields that map one-to-one with the fields in the JSON response, right? Because I've got a data array and string error and an in status code. So I've got a data array, string error, and an in status code. And then in data, I've got ID, first name, last name, email, created at, updated at, which is what you're going to find here in each one of these objects, because this is a data object, this is a data object, this is a data object, and all of them together create a data array. So when I deploy this, missing return statement. Oh, let's go ahead and just return response. Okay, so now the endpoint for this was cn-API. So if I go to localhost/cn-API, all of a sudden I've got all this data. And if I go into the application, you'll see that we printed out each element that came from that Coding Nomads task API, right? So now I've got direct access to each one of these elements. If I hit it again with the breakpoint, just the last thing I'll do just to really demonstrate it is after we make that request right here on line 21, we've mapped all that data from the Coding Nomads task API into this CN response object, and I've got direct access to that. So if I want to go send every single person an email, or if I want to get the average age, or if I want to see, you know, when each user was created versus when they were updated, or whatever I want to do, I can now do that very, very easily because I've got all that data from that Coding Nomads task API that was in JSON. I've now got that in my application as this CN response object. So the last thing I'll do here is debug it. And so here we are in the debugger. I just set a breakpoint and then I hit that URL. And if we look at response.data, here are all those pieces of data from that API. You can see Caden, Martin, Simon, Hank. And if we go all the way down to the bottom, you're going to see, well, there's double click to see. Just a few more. There's that last one that we just created here in this demo. First name Coding Nomads, last name REST API. I've got complete access to all that data from that third-party API here in my application. Very simple, very simply using this REST template. There's several ways to do this. There's some newer ways that Spring's coming out with right now. We can also use this REST template to post for object, post for URL, etc. There's a whole wide world of fun and cool things you can do here that are super, super useful. But hopefully this is a helpful and interesting introduction to working with APIs, creating your own APIs, as well as integrating with third-party APIs.
Thanks, Ryan.
Yeah, you're welcome.
This was great. The only time I've ever played around with REST APIs is from the Python side of things. So it's nice to see all of this from the Java side as well. I knew it was possible. I just didn't know how. So this is a great
Right.
intro. I love it.
Great. Well, any other questions or comments or from anybody that I can help you with before we cut out? Nice. Cool.
We'll take
All
that
right,
as
well,
a resounding no.
Yeah. I guess I just explained it so well, it makes perfect sense.
Yep. Everybody's going to go out and start writing their own web APIs right now, their own REST APIs and everything else. So
Perfect. Great.
The next great app is coming. I can feel it.
Nice. Great. And then what's John, what's the next brown bag? Is that Brandon discussing Python based? He's going to be building a Flask web app, I believe, right?
I believe that's right. Yeah. Well, actually, it's Python features right now in 3.7. So that's the next one. That's in 2 weeks. And then there's we have a break at the end of the month. So we have an opening if anybody wants it at the end of the month. If anybody is interested in presenting, if you've got something cool you want to share, happy to have you along. And then we've got some machine learning stuff from Michael Darling in August.
Wonderful.
So that's what we're looking at this point. So and so we have like I said, we have some openings, and we need to get some more stuff on the schedule past August. But other than that, we've got a couple more things coming up. We're going to have another office hours, just a general office hours, ask questions, kind of talk around each other in July as well. We'll get that scheduled up here in another day or two. So
wonderful.
Yep.
Great. Well, thank you, John. Thank you everybody for joining. And we'll upload this and post this. If you have any questions, if you're watching the recording later, join us on the forum and you can ask any questions here in the post that will contain this recording. And I'm super, super happy to help you and answer them. And everybody enjoy the rest of your day. Thank you for joining and looking forward to chatting with you soon.
Awesome. Thanks, Ryan. We'll talk to everybody later.
Thank you.
Thank you, everybody.
Bye-bye.
Bye-bye.